London. He's part of the ReactNative team, and it's a great opportunity to get a look at the other side of the library. Just wanted to ask an unrelated question while you are all still here. Anyone has anything against conducting a meetup in Herzliya? I asked everyone is fine with the meetup in Herzliya? Yes. Okay, so it's 27.5%. Hand it over to Dave.
Thank you. So, as Doran said, I'm engineer at Facebook. I work on ReactNative. I've only been on the team for about 4 or 5 months, but I do know a little bit about it now. Before that, I've worked in Parse. Shed a tear for a moment. Worked in Parse. I worked in ads at Facebook, and I worked on Facebook platforms, so being able to log in and share things with Facebook through external either apps or websites. So been at Facebook about 4.5 years. How many people, I'm assuming everybody uses React regularly or somewhat regularly, how many people actually use React Native? So, a decent amount actually. How many people do mobile development in general, either for Android or iOS? So good mix. Okay, cool. So today I want to kind of talk about why React Native, why Facebook did it, why we open sourced it, and then dive a little bit into some more details in the architecture. It's actually not going to be quite as deep as the internals of the doc. But just give kind of a high-level view of the architecture, dig into some details, do a quick little demo, and then kind of talk about where Facebook thinks it's going next, and also talk about the community involvement, because there's no question that React Native would not have gotten to where it has gotten to without the community helping out. So those of you who raised your hand know that mobile development is hard. There's 2 major platforms. Maybe you're building for Windows Phone as well, or something older. But each one has different APIs, the different programming paradigms on, different libraries. You have to compile. Like those of you who work in the web world don't really remember this, but yeah. But you have to compile, which takes forever, and so. It's not as nice as the web environment. But native really looks good. Like, there's a big difference between a native app and how it looks and how it feels and how the interaction is for a user than just showing a web page or something like that. And so React Native kind of gives you the best of both worlds. It gives you the development speed of developing for the web, with views and paradigms that are actually native. So you can kind of think about it like, take out the back end of React that renders to the DOM and everything, and replace that with views that are actually UI views on iOS, or Android views, Android view.view on Android. And so it gives you kind of the best of both worlds. And another big thing, and Facebook definitely needs this, we build a lot of mobile apps. We can share code between iOS and Android. So you can build the vast majority of your logic code, your logic in JS, share it between both Android and iOS. And then even a lot of your UI code can kind of be shared between Android and iOS. So we have a couple apps that Facebook has shipped that are built on React Native. And in those cases, I think they share about 75 to 80% code between Android and iOS, which is pretty big. And so we've been able to have teams that can take an app, write it once, and then within a few weeks, even release it from iOS onto Android without ever having been experienced Android or iOS engineers, which is a pretty compelling narrative for Facebook. And we think for others, so. So at the high level, and this is sort of a high level kind of description, then we'll do some boxes and data flows and stuff like that. So it is a set of native modules. So right now React Native is only supported on Android and iOS, though I think Microsoft just this week put up a thing for Windows Phone that we hope to sort of pull into the main branch. A set of native modules and a set of JS modules and a bridge that basically can call methods from one to the other. And a module is just an object with some state and a collection of methods that can be called. And the bridge is just that glue that helps go back and forth between them. So, actually I'll come back to the threading in a second. So we have native code. It's either Java, Objective-C, or C++. These slides are actually lifted from the earlier talk that was specific to Android React Native, but so anywhere you see Java or C++, you can slash Objective-C there as well. So native sends a single JS call over to the JS executor. So we just use JSC on both Android and iOS, and it executes a bunch of JavaScript, and out comes emitted back to the bridge a set of functions that it wants to call in the bridge. And this loop goes back and forth at 60 frames a second. So we can get basically near native performance at 60 frames a second with this loop going tightly back and forth. All the method calls are serialized, they're batched up, it's async, so you can call something and then maybe you don't get the results until later, and it's kind of queued up on the JS side because you have to do a lot more work on native. And this flow is what happens. Let me go back to this. So there are sort of three main threads to make this responsive. One is the UI thread, so that's the app's main thread. If you've ever done mobile development, you know that it is pretty much imperative that you not block that, because anytime you do, then the app stutters, it won't handle touches, scrolls will stop, anything like that. So we try and take everything basically off of the UI thread that is not UI. So all of those native modules that you saw in that green box are basically running in a separate thread. On Android, there's one thread that is shared. On iOS, we actually use Grand Central Dispatch, GCD, which lets us create queues per native module, so each one can independently run on sort of its own thread conceptually. And then there is the thread that's running for JS. Just like in, there's a little bit more detail about the Android specifics and how it works. Just like in React, where the layout kind of happens independently from the actual rendering, we do all of our layout paths in a separate thread so that the UI stays responsive throughout as we're relaying out the tree. So this is kind of what happens. So there's some modules in there, like maybe so we have the UIManager, that's kind of the main thing that manages kind of the DOM. So it allows you to create a view, update properties on a view. Maybe there's a networking module, maybe there's a storage, which lets you to like get, store some data, get some data, delete some data. And this is kind of what happens is in the on the JS side, you might call UIManager.createView text, and this is obviously sort of hidden from an end developer using it. This is kind of what things compile down into. And then that actually gets turned into a message that is just a JSON blob sent across. And so in this case, it's module, method, arguments. And so you can tell that this is a call to the UIManager. We're going to create a view, and this is the arguments to that view. And you can probably figure out that the type of view we're going to create is text, and it's going to have a property foo that has a value bar. And the same thing with storage. You can see storage was module 3 and so on. So that's what the actual bridge is basically doing, is the JS side is kind of emitting this stuff. It's getting sent across over into native, where there's a dispatcher that's running, that's pulling all this stuff off, and then dispatching to the appropriate module. And this is, again, a little bit more detail. So this is kind of shows startup. So in the Java side or in the Objective-C, you basically say, hey, I've got an application that I want to run, and this is like the default state passed to it. So you say my app, so over on the JavaScript side, it will launch that and start executing my app, which will in turn end up creating all of the views to build everything it needs, send that across, and then this will call on the UIManager module, create views, and it knows because you asked for a view to create a view in the Android sense, if you ask for text, it creates text view, etc. And then you can kind of see like what you need to do to sort of start. So if you want to create your own native module, you just extend an existing base module and implement a couple methods. So I mentioned this before, but so the UIManager module basically keeps the virtual DOM. So it keeps the CSS node hierarchy, and it calculates layout changes on that native module thread, not on the UI thread. And then at the point where it knows everything, basically transfers it all to the UI thread with, via diffs and says, okay, this view needs to update this property and stuff like that. And we just use the open source CSS layout engine. This is, like I said, runs both on iOS and Android. There are a lot of common components, obviously. There's text, there's images, there's scroll views, there's buttons, all these kinds of things that are common paradigms between the two phones. But there also are ones that are different. Android has drawers that you can like drag out from the sides. It's got toast that comes up. Those don't exist on iOS. iOS has the tab bar navigation stuff. It's got an API to like vibrate the phone and things like that. Android probably has that. We probably just haven't implemented it yet. But they each kind of have their own special things. And we don't want to build a platform that is sort of the lowest common denominator. We don't want to build an experience that lets you only build for the subset that is in common between the two of them. And so we have kind of built-in escape valves to let you express native concepts on both iOS and Android. And the two ways that we let you do that is you can actually build a module.android.js or a module.ios.js file. And then the packager, at the point where it's assembling all of the JavaScript that's going to be shipped and bundled up with your app, will actually know that you are building for Android or iOS and pull only the appropriate file. Or you can sort of, put an if statement, though it's only 2 as opposed to a big giant switch statement. Put an if statement in your code that branches on iOS and Android. So it's kind of up to you, it's to your choice. We have both in our code. I wanted to switch over into a little live coding, which I know you're not supposed to do in demos because invariably it goes wrong. But I'm going to try it anyway. So, bear with me. I unfortunately haven't updated to like ES6 and classes and everything. This is just our sort of generic playground app that we use internally for testing and stuff. So you can see we've got a React class. It's got a render function. We're going to return a view. We set some styles on it. We're going to put some text in there. It says hello Tel Aviv. Styles are all in line with the modules, so we've got a container. It's everything in React Native is made out with Flex. So we said Flex 1, which means it fills the space. The background color's white, it's got some color. So I can come over here and show you that's what it looks like on Android in the emulator, and that's what it looks like in iOS. It's not very exciting. But we can say, like, we want to add an image, so I'm going to just copy and paste code from next door. So we'll declare the image. And then we'll just stick it after the text. So we refresh that. We come here. Come here over there, refresh that, and you can now see that the image is there. So those of you who have done mobile development, where you have to actually like build, should be going, holy shit, that was fast. Even with copy and pasting and such. This is the kind of speed that you get that you just don't normally get if you're building, because you have to compile everything and rebuild your resources and blah, blah, blah. So, but that's not very interesting. Like, we've put an image there. So let's actually, like, do some, something a little bit more complex. We'll just sort of slowly build this. You can probably follow along as you're... So we'll actually make it stateful. So then we'll come down here. Refresh. And it should look the same since we didn't change anything really. But now, let's make it, that's not very exciting, like mobile apps, you want to interact with them, so let's add some touch capabilities. So we'll just require another thing for touch. And we'll make the that image touchable. So all we did, you can see, is we just wrapped the image saying, hey, when this is touched, put a little highlight. And you can style all this and stuff like that so that it does the right thing. I'll come over. This is Android. Oop, no, that was the wrong one. I have to wait for it. Okay, we'll just go back to, okay, there we go. So you can see you can also debug in Chrome and stuff like that. So let me turn that off just otherwise it'll slow us down a little bit. But you can see I can now touch it, you get feedback. If you want, you can obviously style this. But in the interest of time, I will skip. But we're not doing anything yet right now, so let's actually like do something. So all we're going to do is add an on press there, and we're going to set the city to London. So so now when I click it, it changes to London, but you can only do it the once because we aren't doing anything better. So in the interest of time, let's skip a little bit ahead. I'm just going to copy and paste this whole thing, and we'll kind of walk through what I ended up doing. Hope that works. So now we've got Tel Aviv as our default, and then that's Tel Aviv, this is London, that's New York, and that's Menlo Park. These are all the places where React Native is developed at Facebook. It's not actually developed in Tel Aviv, though it is used in Tel Aviv. But you can see we've just built this kind of quickly. So, you know, we've got initial state of a city, nothing too exciting. We're going to build an array of buttons, which we just, you know, right now said we've got a list of cities and we're going to map them to an individual item. We'll put all of those buttons in a style, so you can see that the buttons ran across. The default for Flex is to run column-wise, so I changed the Flex direction on the buttons to be row. You can kind of see that here. And then in the button item, we didn't do anything other than setting a state. Here's an interesting property. I set a key on this. And the reason I did that is I didn't actually do it at first when I did it. Let me do it in this image. So, notice when I didn't have the key down there, I got a little warning. So, you can click this, and it tells you that if you've got some kind of iterator and array, it should have a unique key property. So this all happens in line to your developer experience. You can dismiss it and come back here and add the key property. If I, you know, incorrectly do something, so if I introduce a compiler, it'll reload and boom, tell you right away you've got a syntax error. If I come here and instead of setting state, let's say if I come, actually, that's going to be, yeah, what's the...
This is a common place in actually.
Yeah. So come here, reload, and hit that. Notice it tells you oops, and then it actually provides you a call stack that links straight to your code, so you can go here and click it, and it'll actually put you on line 35 of your editor. So there's a pretty nice development environment that's very fast to iterate. It's really kind of fun to play with. So let me switch back. So what's next? So those of you who've played with ReactNative, and this is kind of the main thing that I'm going to be working on for the short term, is the API parity between iOS and Android is not great. They were developed by two different teams internally at Facebook at different times. They certainly talked with each other and paid attention to each other's work, but you'll end up with properties that are enabled on one component in iOS, and the corresponding Android one has a disabled property. You will end up with method calls that take callbacks, and some will be success first, then error, others will be error first callbacks, then success. So there's a lot of little things like that that are kind of annoying right now. But we're working on them, we're fixing them, we're trying to fix them in a way that is backwards compatible. So you saw the little yellow warning that showed up. So what we're doing is we are actually moving all of our API basically to promises. And we will, at runtime, detect that you seem to be calling us with a callback and print out a little warning that says, hey, this is deprecated, it'll be disappearing in 2 versions, you need to switch to the promise-based method. So we're doing a lot of work on that, basically pushing it forward to make it a lot more standard. Obviously there's a lot of work on speed, so that's a big concern for people. People think, well, if you're not running native and you're like running JS, isn't it kind of slow? And the answer is no, it's not. But it also is not at native speed yet. So we have a huge, we have a team of maybe half dozen people or something, which is huge by Facebook standards. So we have a smallish team, I guess, working on speed, and so looking at are there different parts of it that we can write in C++ instead of Java on Android? Are there things that we are exceptionally chatty about along the bridge that's causing extra data back and forth? Can we put enhancements into the JavaScript runtime so that everybody benefits from them? And it's a big thing. So internally, we watch this a lot. We want to make sure that if teams are building on React Native, that they can get the performance that they want, that they can get the speeds that they expect for, the user launches an app and it's ready to go within a certain amount of time. Again, more stuff we want to, there's things that exist on both Android and iOS yet that we haven't wrapped. And so, some of those we will probably not do. Some of them we actually take a lot of pull requests from the community, so a lot of times these things come from the community as people say, you know what, I really wish that this widget were available that Android has. I'm going to write a quick wrapper. And it's relatively easy. It's basically, implement a manager class, a module class that sort of shims out to the native view, exposes the properties that you want to expose, then write a quick little JS wrapper around it, and you're good to go. That said, this leads kind of into the next thing. Packaging, bundling, that kind of stuff. Because this is native, there's a native component to that, and so oftentimes it may require, if you are adding a new component, a recompile. If you download, there's plenty of React Native components that people write and put up on GitHub. The ones that are pure JS, you can just kind of npm install and go. The ones that are JS but also have a native side to them because they are shipping native code, you need to explicitly take that code, put it into your actual application, recompile, add it in the proper places in the package manager, etc. So we want to try and make that process a little bit smoother. And then there's a bunch of community efforts, like I mentioned earlier, like porting to Windows Phone, things like that. And I've said this a few times, it really is a community effort. It was developed at Facebook initially, and then we open sourced it. And it is still developed basically on GitHub. I check in code to Facebook, and within 30 seconds, that code is live on GitHub. So you can watch us all work in real time. Facebook runs against master. We're basically always at the tip of the trunk. Externally, we package it up every 2 weeks and call this, I think we're on 0.19. Yeah, 19. So we're on 19, and in 2 weeks we'll be on 20, etc. And that's, just so that the community has a more stable build to work against. But internally, we just go against master. So it's also pretty popular. We've got about 500 plus contributors. I think I checked, it was like 516 or something. 5 of the top 20 are not Facebook employees. And I'm gonna guess that if you go into the next 400, none of them are Facebook employees, because we've only got about 15 or 20 people on the team working on it. So there's certainly a lot of stuff that comes in from the community, and we try to be on top of it. We've set up a lot of bots that try and actively identify, based on who made changes to this file previously, you should ping this person to ask them for the review, and so that all kind of happens automatically. We run Travis and CI tests on everything while we update the pull request, and then we internally, because we have some parts of it that have not been open sourced, internally, we also, when we pull the request and run it against all of our internal tests to make sure things aren't broken. And for the most part, that rarely happens, that we pull something down and it breaks an internal test. And when it does, we almost always push, either take that test as is and push it external, or write some other kind of wrapper around it to get it up there so we can show people in the community. So who uses it? So Facebook, the Ads Manager app, which is written entirely on ReactNative. The Facebook, what we call the Big Blue app, so, you know, the app that you use when you tap Facebook and start scrolling through your newsfeed. There are parts of it that are written in ReactNative. I'm not sure I can say which parts right now, but there are parts of it. And then just launched yesterday, 2 days ago, was Protect for Android, which was developed entirely here in Tel Aviv, in this office, from the Onavo team. And then there's dozens and dozens of external apps. So TaskRabbit, there's a guy at TaskRabbit who writes about ReactNative a lot that does really good work about it. Exponent, which if you want to just play with ReactNative and don't want to go through any of the setup or anything, is a great app to use. Exponent basically lets you just kind of go to this, like you can just go straight to writing code, and then you like upload it to the Exponent server, and then it automatically is like found on your app. Discord is another thing. Like these are ones that have either explicitly reached out to us or we kind of know about. And then the ReactNative community on Facebook, pretty much every week there's some sort of announcement of, hey, we just launched this new app on it. There's tons of sharing about, oh, I built this new component, or what do you think about this? Lots of job opportunities too, that people post about. So what can you do? So you can contribute. We always welcome contributors. So github.com/Facebook/ReactNative. I was kind of curious. I did a query for ReactNative on GitHub, and there were over 4,000 repositories. And that is people creating different components that they wanted or needed. So it's a very active community. We use product panes for people voting on issues. So if you are using it and something is bothering you and you really want to, like, GitHub issues don't really work very well because you end up with lots of +1s on them, and it makes it a lot harder, so we use product panes. And so we've actively been working at kind of knocking through the top product panes that people are having about, oh, this function, this feature doesn't work, or it's not the same on Android and iOS, or it would be really cool, iOS 6 added this, you should add this too. And or join that Facebook group. It's called ReactNative Community. And I think that's it. Yeah, so I'm happy to take your questions.
I actually have two questions. First is the CSS modules thing. Well, you've got like your internal styles, you have inline styles. If I would like to do theming, for instance, I don't have like in CSS modules. I got like column mobile, for instance. How would you do it here? Just first, okay.
Yeah, so the question is about using CSS modules as opposed to inline styles. So we certainly bias toward inline styles. I have seen someone posted actually a really interesting article that they had written where they basically like rebuilt kind of global styling stuff in CSS. And so it is possible. It's not sort of the mainstream, like easy path.
How would you do themes?
I don't have a good answer for you.
Okay, so it's okay.
So
it's important.
I will take that note.
And my second question is, well, I do mobile development through Portal, I know Phobia and all that, and so we work with a web view. I wondered if you can create a complete flow with JavaScript, which does not relate only for the component. For instance, the basic things, Ajax calls, stuff that the browser gives you, which is not like, you know,
Yeah, so we basically inject into the JavaScript framework things like XML, HTTP requests and stuff like that. And there's nice wrappers for them, so you can do, you know, new request.fetch, and now do an inject
so I can write an entire application on JavaScript without doing any Objective-C, Java.
So you have to do a tiny bit for the shim. So basically, you know, you have to compile it to like a native application, so a .app or whatever it is on, and a .apk on Android. So you have to do that little bit, but that is all boilerplate, and if you use the ReactNative command line that we ship, you just, you know, ReactNative start new app or whatever. I don't actually know what it is off the top of my head, but that'll basically build you a hello world. And all you then need to do is start filling in JavaScript. So, yeah.
Does it support Swift or only Objective-C?
So the question is whether it supports Swift or Objective-C, or only Objective-C. We currently don't have any modules written in Swift that I know of. I don't know enough of iOS internals to know what you need to do to use both at the same time, because I know you can. So my guess is you could probably write your modules in Swift. You're going to have to probably jump through some more hoops on the native side. But that you could probably get it to work, because we basically, modules are just kind of registered. And we even do it dynamically based on like annotations kind of stuff. And so if your Swift module is able to sort of provide that annotation saying, hey, I am a native module, and you can load the Swift runtime in the same place, because I think that's probably going to be the tricky part. But that also is probably a standard like iOS thing. I'm not an iOS dev, so I don't know for sure. But I'm guessing you could probably make it work. Yeah.
Two questions.
I'll leave it in.
Okay, so first question is like Flex is quite opinionated way of styling, and it doesn't enable me to do some stuff that, for example, making one view 73% of the phone, I cannot do it. Are you implementing something else?
So Flex is sort of the standard way we express layout, but you can also express things explicitly. You can say this is where the top left is, and this is the size and the width. And you can set up on your component basically an on-layout call that will hand you the dimensions of the screen and things like that, and so you can grab the dimensions and say I want to be 0.73 times whatever the width is, and so you can do that kind of stuff.
And second question, are there any plans to make the web browser another platform, and then you write view and text and it will become div and span?
To run. So the question is whether there are plans to make the web browser another sort of display where you could write view and text. I don't think so. I don't see any reason we would want to introduce the web browser. Like the point of ReactNative is that you get the native performance using the actual underlying native views. Maybe there would be some call to like take some of the components that we have in ReactNative and push them back toward React. Maybe, I don't know. So, yeah, sorry, you were...
If you could share basically three intentions, if you can, regarding moving most of the components partly in a native way to ReactNative and not one.
Sorry, can you share our intentions with regards to...
Moving most of the native components to be ReactNative, and if not most of them, why not?
Do you mean as we build our own UI and...
Yeah, with only ReactNative.
So Facebook builds a lot of mobile applications. I mean, most of you probably use one or two, but we've actually got like a few dozen that we build. And we've spent a long time as a web company, and so it has taken us a while to ramp up on mobile. At this point, I think we're there. We have some world-class mobile engineers. But we also now, if you want to build a product, you have to have web expertise, you have to have Android expertise, you have to have iOS expertise. You know, in the future you may need to have like VR expertise, Oculus, you know, who knows. And so React Native enables us to basically take people who've had years of web experience and transfer that to mobile. And so we have been, like I mentioned earlier, we have a lot of internal components that we have not released because they are Facebook themed, Facebook specific components. So, you know, they are the like button and things like that, so that we have an internal library of all these components that are really just for Facebook. And it's really around like the theming and stuff. When other teams build components that like maybe the scroll view is not working great or something like that, and another team builds their own scroll view, we oftentimes take that code back into the open source and improve our existing components. So I don't know if that answers your question or not.
I'm wondering if it will be like a performance-wise question, you know, not all of this will work.
Yeah, so ideally, like the team would love to get to the point where we're building most stuff on React Native. Like I mentioned, performance is one of the big things that we are focused on as a team. We are not at native performance in an apples-to-apples comparison. So if you build the component in React Native versus build it in just iOS or Android. But we're getting closer. We are, without saying specifics of numbers, we're much, much closer than we were 6 months ago, and we anticipate being able to get within, you know, a few percent kind of thing at some point. And we think that will be within sort of acceptable tolerance, and that the benefits of being able to share code, have less specific expertise on your teams in Android and iOS and web, and being able to sort of build it once, and then put a little bit on each kind of platform to make sure it looks just right on each one is going to be overall faster. Is that good or take more?
How many? Let's take a couple of minutes.
I can stay here all night.
What standard of JavaScript you use?
What, sorry?
Standard of JavaScript. Is this some engine language with the 6, 7? Babel compiler is inside?
Yeah, so we use Babel inside, and so we kind of take it all. Like you saw, the stuff I had was not actually ES6, where we were class foo, extends React component. It was still the kind of old style. We have a mix. It's not something that is super high priority for us to go and like sweep across all of the code and update the styles. So generally when we go and make changes to a file, we'll kind of bring it up to the latest standard, which we're using sort of the ES6.
No, what can I use, what I cannot use? What kind of stuff I can use from ES6, for example?
Everything.
Okay, last question.
Sure.
Well, React Native is sort of more of a front-end library. What about the back-end of the client?
So,
And corollary to that, what about wrapping native components on the back-end, such as location management, push notifications, and stuff like that?
Okay, great question. So the question is, React Native is very front-end. What about back-end components, and then also wrapping back-end components and exposing to JavaScript? So you're right, React Native is very much about the view, about display, but you can just require relay and suddenly relay works, and so you can get all of your GraphQL and all of your data fetching and all that kind of stuff. So it's sort of works happily in the general React framework. I think there's probably going to be some gotchas in there, but we're like pushing that way. As for native components, things like location services and stuff like that, a lot of those we already have wrappers for because we use them in Facebook. And so you can, what you saw are really more components rather than modules in our terminology that we use, where components are really for visual, they are views. Modules are more what you think, like not view, they are just sort of pieces of functionality. And so there is a geolocation module that you can subscribe to, and it'll like call you back when the location changes, and you can sort of prime it to say, hey, I want to know the location now. So a lot of those things are built. If you find that there are things that you want to use that are are capabilities on the phone that exist, but we haven't exposed, go to the product pane site and say, hey, why isn't this there? Or read yourself, and then we'll, pull it in.
What the hell happened with parser?
I don't know what the official company line is, so I'm not going to actually answer that. I think it was just sort of not core to Facebook's business. And it makes me a little sad because it's had a great community reception. But I think we're trying to do a reasonable job. We've basically open sourced the parse server so you can take it and run it yourself. And it's got a year lifespan, so you've got a year to be able to sort of figure out how to migrate off it or migrate to your own instance of it that you can run. Sorry? Oh, thanks. Right.
Thank you very much. Another big round of applause for the three speakers who put a lot of time. I hope you keep on coming to the meetups and follow the publishing and join the Facebook group, because it's only worth it if you guys attend it. Thank you, guys and girls.
לא, זה מאוד